Good morning, students.
Morning, madam.
It is not good morning, it is good evening, student.
Good evening, madam.
Student, I'm not hearing your voice, is very low. Okay, that is great.
Good
Today we are
evening.
going to pass through curricular spirit. Good evening, student.
Good evening, madam.
Today we are going to pass through curricular spirit. And we are going to look at the coordinates and how they are plotted on a polar graph. And those are the objectives. You understand the knowledge of polar coordinates. You understand how to plot them and how to apply that knowledge in real life time. So let's begin. So the polar coordinates, are you seeing my notes?
Yes, I see them.
Okay. Now in a plane, there is a point of origin and an axis through that point. So on the point of origin, there is an axis that passes through it. It is either an x-axis or a y-axis. So now the polar coordinates, they are in the form of r, theta. R meaning the radius and theta is the angle. So these points, like I've told you, R units is the distance from the origin, and then the angle, the theta is the angle from the x-axis. Then the value of theta may be given in degrees or radians. So to convert the polar coordinates, to convert polar coordinates to the Cartesian like that, x equals to r cos theta and y equals to r sine theta. But those are the Cartesian coordinates, because Cartesian coordinates is xy. But then polar coordinates is r and the theta. So when you are converting again from the Cartesian to the polar coordinates, you get your r. Of course, you have this x squared plus y squared is those are the Cartesian coordinates. So r equals to the square root of those two.
Yes.
And then since tan theta equals to y out of x, then the theta will be, so the Cartesian paired the coordinates are xy. When you convert them to the polar paired coordinates, you get the square root of x squared plus y squared, and then our theta will be tan inverse of y out of x. You get?
Yes, I get, madam.
Okay. Now, we are going to use this as our original example. Say you are given a point coordinates xy from the origin and the angle measured. This gives the polar coordinates as r and theta of p. Remember our point was p. So now, as you see here, are you seeing where my cursor is pointing?
Yes, I'm seeing, madam.
Yes, our x-axis and the y-axis, let us say those are these ones, x and y, are the Cartesian coordinates. So now if X and Y are the Cartesian coordinates, the distance from this origin O to where that point you are seeing XY is radius, and then the theta comes from the x-axis R. That's how it is drawn.
Yes.
Have you understood it?
Yes, madam.
So as you're seeing from this table that I inserted here, if your equation is in any of the two, either the polar form, and you are asked to look for the Cartesian, R squared is equal to X, that is the Cartesian form. But if it is in the Cartesian form and you're asked again to go back to the polar form, of course, X squared plus Y squared is going to equal to the R squared.
Yes.
And then the point, the Cartesian form will be X, but this side of the polar form, it will be R cos theta. And the Y will be R sin theta. Have you understood it?
I beg your pardon.
Yes, now X as the Cartesian coordinate represents the polar form R cos theta.
Yes.
And then Y as the Cartesian will represent students. Are you hearing me?
Madam, your network has been off the screen. I'm not seeing it.
Okay, let me share again. Are you seeing my screen?
Yes, you're still sharing.
Have you seen it?
Not yet. Yes, I've seen, madam.
Okay. Now, as I was still telling you,
Yes.
the R distance in the polar form.
Yes.
Okay, if your equation is given in polar form, it will be R squared.
Yes.
Looking for the Cartesian form, it will be X squared plus Y squared.
Yes.
And the X squared, X and Y, you see them down here. Those points, you are seeing them in polar form. X is the R cos theta and Y is R sin theta. Have you understood it?
Yes, madam, I've understood.
Okay. Are you seeing the next slide?
Yes, I'm seeing.
Yes, now we're still talking about the other points that have shown you where your r squared is equal to x squared plus
That's
y
good.
squared, and your tan
Square
will
plus.
equal to, okay. Now the conversion is that theta is positive if it is measured counterclockwise sense. Do you know the counterclockwise sense?
Yes. It is the rotation counterclockwise. Follow
Okay, if you
like this.
know it, then anti-clockwise. Do you get that sense?
Yes, madam.
Okay. Now, if r is less than 0, if r is less than 0, then it is measured in the sense of r magnitude. Do you know what r magnitude means?
No, madam.
Yes. Now, if you put the negative r in magnitude lines, it becomes a positive. So in other words, you will notice that r negative r theta is the same as r positive r theta. So an example is this one that you are seeing down here. Are you seeing my example?
Yes, I'm seeing.
-1 pi out of 4 and 1 5
5
pi
pi
out of
out of 4.
yes. Now, what is that radian, rad, what is it? When you divide pi out of 4, what do you get?
Pi out of 4, I'm going to get 45.
Okay, now you measure the 45 here from the x-axis counterclockwise to r to the point P. Okay, let us call it point P. You measure it. Yes, now when you measure it, the opposite angle this side, again you measure it from the x-axis to point Q. And since point Q is -1 pi 4, you can still call it 1 5 pi out of 4. Have you understood that?
Yes, madam.
Okay. Now we are going to the point of plotting. When you are told polar, what do you get?
Polar. The polar, you know, is of chemistry.
Now we are in the sense of math. The sense of math tells us that polar will take you to a circle. Those are the points on a circle. Because you have quadrants, and of which quadrants are related to a circle, because a circle has 4 quadrants. So in those quadrants is where you get those other coordinates that you are going to plot. So now An example of plotting polar coordinates is this one that I've given you here. So we are given that we may plot 2, pi out of 6 and negative 2.
2 pi out of 6.
Yes. Now pi out of 6 is 30. So for us, we are not, we shall bring back the radian part after we are finished with everything, because we are not well versed with anything yet. Now you get your protractor, or you get your compasses and what, and then you measure from here. You're going to measure from where? From this x-axis here.
And we measure 30 degrees.
From this x-axis, yeah, and you measure 30 degrees to this point 2, because, okay, when you first get the what? You first measure this R, this one here. So when you measure that R, because it is 2, when you measure it from the origin 0 to this point here, let us say our point is oh, Jesus Christ. Let us say our point is P. Our point is P, it is 2 pi out of 6.
Yes.
So now you measure from here, from the origin here, this origin here,
Yes.
to this point P that we stated. This pencil has refused, but I've tried. So I was still telling you, you measure from the origin O, which origin is here. Let us say from this origin to P.
Yes.
So when you measure again the opposite angle of that same line, going like, okay, let us call it parallel. So when you measure it parallel again, you get another point, but this point is in the third quadrant, which makes it negative.
Yes.
But how many points do you think we can get from there?
The points which are along the same vector line.
Do you know that we can get 4 points from there? Yes, along that same vector line.
There are many points.
Yeah. So now, if we measure from here like this, we measure this. Do you know that we can still measure from this x-axis up to here? We can measure from the x-axis. Let us say this point is Q.
Yes.
Have you understood?
Yes, I'm getting.
Yes, if that point is Q and this point here.
Yes.
Okay, we measure from x-axis to the y-axis. I mean to the point, to the line that goes to point Q. And then we can still measure from here to, from the x-axis but student, hello student.
Yes, madam.
Yes, I was still saying that you get, those are now how many angles?
There are one there. We have in just two.
Now we have this angle here, this one, we have this one, and we also have this one. Those are three angles. Do you see them?
Yes.
Then we can still measure from this x-axis. From this x-axis to this point, to this line that goes to point P. So when you measure those are 4 points. So the next slide we are going on, you see, it shows, okay, no, this next, let us go to the next one because we have less minutes left. Excuse me, let me first grab something. Okay, let's continue.
Yes, madam.
So yes, as I was still telling you,
We skipped some slide.
yes, we skipped some slide. So yes, we skipped some slide. I don't know, electricity is off,
Oh, sorry, teacher.
but we're almost done. So I was still telling you that the other 4 points that we got, we look at this example here. Are you hearing me?
Yes, I'm hearing you.
Yes. Now if you're hearing me, then you see the other points that we got?
Yes.
They are not the same points as this, but we can relate them to this. These are 4 points.
Yes.
These are 4 points.
Giving the same.
Giving you just the same point like this.
Yes.
Just know that when you come from the x-axis in the fourth quadrant, to this point here that we call D. So if you x-axis in the fourth quadrant, going to the third quadrant to point Q, you will see that that point is negative.
Yes.
Taking us to a negative point, like a negative R.
Yes.
And this point coming from the first quadrant, still going to the third quadrant, it is positive because it is coming from, it is moving in the counterclockwise sense.
Yes.
and then others follow. You will follow from there. Something coming from below. Okay, the real clockwise sense, that one will give you a negative. But coming from counterclockwise sense, it will give you a positive. Do you understand that?
Yes.
Okay, well and good. You said we skipped a slide. Yes, this slide that we skipped was telling us that the other negative 2 that we got
Yes.
can still be a positive,
Mm.
but instead of 7 of 6. What is 7 pi out of? Yes, we're still saying 7 pi out of 6 is 120. I mean, not 120, it is 20. It is 210.
210.
Yes, it is 210. Do you know that it is the same point as this negative?
Yes, I know.
Okay. Now, the coordinates 2, 7 pi out of 6 tell us that to rotate an angle 7 pi out of 6 from a positive x-axis, this would put us on the dash line in the sketch that we have just seen above,
Yes, madam.
as we are moving out in a distance of 2 or centimeters or what, but it is 2.
Okay, madam.
Now, the last thing is a take-home exercise.
Yes.
Note it down and you do it in ask anything that you have not understood.
Thank you, madam.
You're welcome.